So the project on a whole is all centred around sustainability for the agricultural sector, but also for increasing the value of human food products. So we're looking at reducing specifically enteric methane emissions from ruminants, which we know is such a big focus area now as well. We've got some guidelines that we're aiming towards to reduce methane in Northern Ireland by 46% by 2050. So my project is aiming to find a solution that is sustainable, because it's a natural product, being the seaweeds, that would then hopefully help the agricultural sector to reduce methane emissions. There's 3 different types of seaweed. There's reds, there's greens, and there's browns. And across them, there's over 3,000 different bioactive components. So dependent on the type of seaweed, depends on how it will work against methane mitigation. So for example, the brown seaweeds that we have here on the coast of Northern Ireland, they contain fluorotannins, and they're analogues to condensed tannins that we'd find in some terrestrial plants such as willow or like legumes or clover, and it has a similar mode of action, so actually it'll also help, fingers crossed, with ammonia inhibition as well. Whereas the red seaweeds, they contain halogenic compounds such as bromoform, and they're a little bit more potent in their methane mitigating effect. So yeah, it's very much species dependent on how it would actually work within the animal. So the seaweed then, we would then collect the seaweed, or it'd be harvested either in a commercial system, or people would actually go and gather it from the shorelines. It would be dried and ground down into a powder. So this can then be mixed in with the animal's mineral or into the total mixed ration. So there's different applications. Some of them are also mixed in with oil, so it has a carrier, and make sure that we get that feeding rate accurate. And then at a farm level, obviously dependent on the species, is dependent on the inclusion rate that you'd put in, but it's quite an easy way to deliver the seaweed to the animal. So far there's been a range of both lab-based and then animal-based research studies that have been carried out. So in the lab, it's in vitro work mainly, where you'd collect rumen fluid from a live animal or post-slaughter at the abattoir. You'd mix that in with the seaweed in a closed jar, and then you'd monitor the gas production over time. So we have an idea at a base level and been able to screen a variety of different seaweed species before then going on to the animal feeding part of the research. Other research groups have already started looking at animal feeding experiments. There's been a number on brown seaweeds and red seaweeds now, and it is showing great promise. So we're very optimistic here at Queen's that we'll be able to get some repeatable results, and with the help as well of AFBI, then it'll be really great to see the outcome in the next couple of years. So we've just started the animal feeding trial at AFBI Hillsborough. That's with dairy animals, and there's also a beef study coming up later on in the year. So both of those are supported by AFBI and through the collaboration here at Queen's. So there's different seaweeds that are being provided, just so we've got kind of a range on those top ones that we've screened. And yeah, hopefully by the end of next year, we'll have some very interesting results to share. The research that we're carrying out on seaweeds, we're hoping for a commercial application at the end of it. We know the importance to provide solutions that can be implemented to the industry. It's all good being in a very much a research bubble within universities, but without the practical application, then it kind of reduces the impact. So for us here, we're very hopeful that this could be something that can be used by the feed sector and implemented to help meet those methane reduction targets.